I'm going to go over a few problems from the Math 3 Unit 9 Worksheet 8, Applications of Logarithms. So number 1 says, a person invests $500 in an account that earns a yearly interest rate of 4%. How much would this investment be worth in 10 years if the compounding frequency was once per year? Show the calculations you use. So that's part A. Part B is how much would this investment be worth in 10 years if the compounding frequency 4 times per year? Show the calculations you use. So we're going to need to use this formula here. A equals P times 1 plus R over N to the NT, where A represents the future value of the investment, P represents the principal investment amount, R represents the annual interest rate, N the number of times that interest is compounded per year, and the number of T is the number of years the money is invested or borrowed. And important to notice, for R needs to be in decimal form, not percent. So A equals P times 1 plus R over N to the power of NT. So in this problem, we want to find A. We know that P is equal to $500. R is equal to 4%, but as a decimal, that would be 0.04. N is 1, because we're compounding it once a year. And T is 10, because we're going to invest it for 10 years. So plugging that into this formula, so we need to find out what 500 times 1.04 to the power of 10 is. So using a calculator, you have to do the exponent first. So 1.04 to the power of 10. Hit enter, and then times that by 500. And we end up with $740 and roughly 12 cents. So that's approximate. The part B still has T as 10, still has P as 500, still has R as 0.04, but what happens now is instead of compounding the investment once a year, we're compounding it quarterly or 4 times a year, so N now becomes 4. So if we want to find A, plug it into this equation. And so that's going to be 500 times 1.01 to the power of 40. So 1.01 to the power of 40 you find first. After you find that, multiply that by 500. And this comes out to be about $744.43. So same amount of money invested, same amount of time, but because one place compounded it once a year and the other one compounded 4 times a year, the one that was compounded 4 times a year made a little over $4 more than the first case. Let's look at number 4. A person invests $350 into a bank account that promises a rate of 2% compounded continuously. Write an equation for the amount this investment would be worth after t years. Well, because it says compounded continuously, we actually use a different formula than we did in number 1. So A equals P times e to the power of RT, where A is the amount that you get, P is the principal invested, E is your mathematical constant. Remember, it's roughly 2.7. R is the interest rate, yearly interest rate, and T is how many years it's invested. So in this problem, we're looking for, so write an equation to see how much it will be worth after t years. So we don't know what t is yet, but we know that R is 2% written as a decimal, so 0.02, and we know P is $350. So our equation would be A equals 350 e to the power of 0.02 t. Part B asks how much would the investment be worth after 20 years. So we plug 20 in for t. And so we want to find out, well, what is 0.02 times 20? And you get 0.4. And then you find out, well, what is e to the power of 0.4? And then times that by 350. And I get $522.14. And then part C asks to determine the time it will take for the investment to reach $400. Round the year to the nearest tenth. So here we're given our principal, and so if we, not principal, that's the amount that we want. Principal is still 350. So if we want our value to go up to 400, we invest 350. So we want to make 50 bucks. So we want to solve for t here. So first step, divide both sides by 350. And you get 1.142. 8. Well, you know what? I'm going to leave it in fraction form until the end. So divide both sides by 350, you get 400 over 350 is e to the 0.02t. We can reduce our fraction, divide by 50, and we get 8 over 7 is equal to e to the power of 0.02t. So we want to solve for an exponent, and that's what logs are for. So I'm going to take the natural log of both sides. I'm picking natural log because the base of my exponent is e, and the base of my natural log is also e. Use the power property. And the natural log of e is just 1, so that's going to go away. And now we have the natural log of 8 over 7 is equal to 0.2 times t. And so I'm going to divide both sides by 0.2, and you get natural log of 8 over 7 divided by 0.2 gives us about how many years we're going to have to wait to see this 350 grow to $400. So in my calculator, I'm going to find the natural log of 8 over 7. And I'm going to divide that by 0.2. And I get a decimal value, and then to round it to the nearest tenth. So I get 0.7 is equal to t. So 0.7 years, or 7/10 of a year.